Alright guys, so in this video we're going to be talking about angles and their measures and the difference between degrees and radians, which we talked about in the last lecture. Alright, so let's start real simple. Angles, what are they? Angles are created by connecting two rays at their endpoints. So they look like the hands of a clock, right? Something like this. And they can really be in any direction that we want, right? So these two rays that are connected, they could look like this. They could look like this, and they can look like any which way you can think about. But when we have so many different rays and so many arrangements of it, it makes it a little bit more difficult to really talk about the measure of the angles. So what we do is we put these angles in something called standard position. So what is that? Standard position is that we keep one of these rays on the horizontal or the x-axis. So this is an angle in standard position. You see how this guy right here is on the x-axis. We fix this guy, and then we let this other ray right here, we let it rotate around our initial side freely. So we have names for these guys. This one right here, the one that's fixed, we call him the initial side. So this guy is the initial side, and then what we call the free roaming ray, we call him the terminal side. So just keep that in the back of your mind as we keep moving forward. Okay, so one thing we should talk about is when these terminal sides start rotating, it can rotate in two directions. It can go either this way, right? Or it can start rotating this way. So if my terminal side starts rotating counterclockwise, meaning the opposite direction of a clock, this way, we say that theta is a positive angle. So if my terminal side moves counterclockwise, if it's rotating the opposite direction that a clock would, then we say that this angle measured theta has a positive value. So what if it goes clockwise, right? If it goes clockwise, meaning if my ray started at the same point that the initial ray started at, and it started rotating clockwise like this, then we would say that this angle measure, theta, has a negative value, right? So counterclockwise means positive, clockwise means negative. And that's kind of counterintuitive. All right, so what are the two most useful angles for us? Well, it's the right angle and the straight angle. So the right angle, as we know it, is the 90-degree angle. And the straight angle is two 90-degree angles put together and they create a straight line, right? So if you make as many right angles as possible by letting your terminal side rotate all around, you'll end up getting 4 right angles, right? If you'll get 4 right angles like this, and what's going to happen is you're going to split your grid, your plane up into 4 sections. So this 90-degree angle, we call this the first quadrant. This second 90-degree angle, we call this the second quadrant. This 90-degree angle contains what we call the third quadrant, and this 90-degree angle contains what we call the fourth quadrant. So notice that our plane is now split up into 4 different quadrants, and you have to know the way they're numbered. The top right is 1, and it rotates counterclockwise. It goes 1, 2, 3, and 4. And it's a specific order, and it's going to come in handy later in the semester. So be mindful of that. Okay, so in the last lecture, we spoke about degrees and radians. Remember, I gave you this little chart, and then we solved some things about triangles. We made a statement how we said cosine of 45 degrees was square root of 2 over 2. Tangent of 30 degrees is square root of 3 over 3. And sine of, I don't know, 30 degrees is 1/2. Okay, and we also had this list right here of radians. So this column says that 30 degrees is equal to pi over 6 radians. It also says that 45 degrees is equal to pi over 4 radians. So in the same sense, we could say that sine of pi over 6 radians is equal to 1/2. Cosine of pi over 4 radians is square root of 2 over 2. And tangent of pi over 6 radians is square root of 3 over 3. So we use these in examples, but we didn't really talk about what they are, right? So what are degrees? Well, unfortunately, degrees are kind of just like random, right? They're kind of arbitrary. So as we know, in a circle, there's 360 degrees. And why did they pick 360 degrees in a circle? Like I just said, it was kind of arbitrary. And a lot of people hypothesize about why they chose that numbers. People say that 360 is divisible by a lot of numbers between 1 and 10. They said the Sumerians back in the day, who, they had a system that was based on 60. They had a base 60 number system. So maybe that's why people also estimated back in the day that there was 360 days in the year, not 365. So that could have been an idea. But the fact of the matter is that 360 was kind of an arbitrary number and it had no mathematical standing. Unlike radians. See, radians actually has a mathematical meaning to it. So 1 radian is equal to the angle measure when the arc length rotates. Well, you'll see in 1 second. It's too hard to explain through words. Okay. Can I zoom in? Good. All right. So here we have a circle. This line right here is my, come on, highlight. Okay. This line right here is my initial side, so it's staying completely still. And this guy right here, he's my terminal side. He's going to be rotating. He's rotating, and what he's going to do, he's going to rotate all around this entire circle. But I want you to notice the length of that terminal side. His length is 1. And what's going on this purple side? Well, this purple side is mapping the path of this circle that you've traveled. Okay, so when I've created this angle theta, I've covered this much of my circle, right? So how much or how long of a path have I walked on this circle? Well, let's just say it was 0.5 something, some unit. Because the terminal side's length is greater than the path walked on this circle, then the angle measure is less than 1 radian. However, if the terminal side length, in this case it's 1, is equal to the path walked on the circle, so see how the purple length is 1 and the length of this arm is also 1. Because the length of the arm and the path walked on this circle up to this point is also 1, then we would say that this angle has a measure of 1 radian. So that's how we define 1 radian. 1 radian is the angle measure when the path walked around the circumference of the circle is equal to the radius. The path walked around the circumference of the circle, so the purple line, is equal to the length of the radius, the green line. So when those two things are equal, we say that the angle measure is 1 radian. So what does it mean then if the purple line is twice as long as the green line? Well, if the path along our curve is twice the length, if the arc length is twice the length of my terminal side, then we say that's 2 radians. So how do we generalize this? We generalize this as saying that theta in radians is equal to the length of the arc, the purple side, divided by the length of the radius, which was the green side. So the length of the arc divided by the length of the radius will give us theta in radians. Okay, so the question that we should probably figure out is how many radians are there in a circle? Well, let's use this above generalized formula to help us solve that, okay? Well, the total length of the total length of the circle is also known as the circumference, right? And the length of the radius is just, well, the radius. So do you guys remember what the formula for circumference was? I know we haven't really used this too much, but okay, the formula for circumference is 2 pi r. And the radius is referred to as just r. So I have an r in the numerator, and I have an r in the denominator. So guess what? They end up canceling out. So I'm just left with 2 pi. That means in my circle, I have 360 degrees, and I have 2 pi radians. All right, so there's an equivalence. 360 degrees is the same as saying 2 pi radians. Okay, so that's good. So we have a relationship. We know that there are 360 degrees in a circle, and that's equivalent to saying that there's 2 pi radians in a circle. But how do we convert between radians and degrees? All right, how do we convert between the two? The strategy here is to set up a ratio. See, what we're going to do is we're going to make 2 columns. On the left column, you'll have only radians. On the right column, you'll have only degrees. And what you want to do is this. You want to set up your problem where your numerators are equal to each other. So this amount of radians is equal to this amount of degrees. And in your denominator, what you're going to do is you're going to have this amount of radians is equal to this amount of degrees. All right, so the numerators should equal each other, and then the denominators should equal each other. And this is how we're going to go about solving or converting between radians and degrees. So the question here is, what is 90 degrees in radians? So first of all, this green and purple combination, or green and pink combination, looks really cool. I like it. Anyway, so what is 90 degrees in radians? Well, I'm going to set up this same scenario right here. All right, I'm going to set up my numerators equaling each other and then my denominators equaling each other. So I need to pick 2 known values, one that's radians and one that's in degrees, that are equal to each other. But we just found one. We said that 2 pi radians is equal to 360 degrees. So that will be our numerator, okay? And what's my denominator going to look like? Well, I want to know what 90 degrees is in radians. So in this denominator of degrees, I'm going to put 90 degrees. And in this bottom denominator for radians, I'm just going to put x, because that's what I'm looking for. So this sentence here says 2 pi radians is equal to 360 degrees. Perfect. My numerators equal to each other. And my denominators say 90 degrees is equal to x radians. Perfect. They should equal each other too. All right. The only thing is that we don't know x. So let's go ahead and let's solve for x. Okay, so the first thing I'm going to do here is I'm going to cross multiply. Cross multiply means I'm going to multiply these guys together, and then I'm going to multiply these two together. See, I'm making a cross. I'm making an x. I'm cross multiplying. So therefore, I have 2 pi times 90, and then I have 360 times x. Notice how I got rid of the degrees sign and the radians, because right here I have, you can think about the units as almost variables. See, I have radians divided by radians, so I can get rid of this radians unit. And then I have degrees divided by degrees, so I can get rid of the degree unit. If that was confusing, don't worry too much about it. If you take chemistry or something like that, you should probably know it. Okay, so the next step, I'm multiplying 2 times 90, which is 180, and I'm just leaving everything else alone. So the last thing I need to do is isolate x. So the only thing connected to my x is this 360. So I'm going to go ahead and divide both sides by 360, and I'm going to simplify. So that means 90 degrees is equal to pi over 2 radians. 90 degrees is equal to pi over 2 radians. All right, let's do one more. What is 3 pi over 2 radians in degrees? All right, so I'm going to set up my ratio again. What's my numerator? It's almost always going to be 2 pi radians equals 360 degrees, because that's where we started off. Those are the two radians and degrees that we know that equal each other. So here I have my numerators matching up, and now I got to get my denominators matching up. So 3 pi over 2 will be my radian denominator, because I want to convert that into degrees. So I have 3 pi over 2 in the denominator for radians, and I have x as my unknown degrees on the right-hand side. Okay, so let's do the same thing. Let's cross multiply. So cross multiply, I'm gonna multiply these two together, and then I'm gonna multiply these two together. Man, I'm really liking this pink and green combination. Looks so cool. Okay, so I'm left with 2 pi times x, 360 times 3 pi divided by 2. And we're going to keep going ahead. We're going to simplify. 360 divided by 2 is 180. So I'm left with 180 times 3 pi, and nothing has happened on the left-hand side. And then I'm left with what? Oh, I got to divide. I got to divide by 2 pi on both sides. So I have 3 pi divided by 2 pi. These pi's end up canceling out. Pi divided by pi is just 1, so I can get rid of that. And then I have 180 divided by 2, which is what? 90. So all I'm left with here, after the pi's cancel out and the 180 and the 2 simplify, I'm left with x equals 90 times 3, which is 270. So what does this mean? This means that 3 pi over 2 is equal to, that means that 3 pi over 2 radians is equal to 270 degrees. And lastly, let's look at this little map right here, these two charts. This is a circle where all of its angle measures are in degrees. And this is a circle where all of its angle measures are in radians. So you can see how they're corresponded or correlated to each other. So this says that 90 degrees is equal to pi over 2 radians. 150 degrees is equal to 5 pi over 6 radians. Let's see, let's pick another one, another random one. 330 degrees is equal to 11 pi over 6 radians. Now honestly, the ones you'll need to know the most are in the first quadrant right here. So you have to know 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. You'll also need to know the cross. So you'll need to know 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And you should know their equivalences. So you should know, oh, and of course 360 degrees. So you should know 0 radians, pi over 6 radians, pi over 4 radians, pi over 3 radians, pi over 2 radians. Notice how these are like decreasing, these numbers. You should also know what 180 degrees is equal to. It's equal to pi radians. You should know what 270 degrees is equal to, 3 pi over 2 radians. And you should know what 360 degrees is equal to, 2 pi radians. If you remember the first quadrant, and then these extra guys on the cross, you'll be golden. It takes a little bit of, unfortunately I have to say this, memorization, but it's not too much, all right? But it will be on your final, so I suggest you guys start studying sooner than later.